Let's work on one more exercise. Suppose government purchases increase by $1 million. How much will be the increase in aggregate demand at its current price? We are given marginal propensity to save, and we are given marginal propensity to import. So why don't you pause for a few minutes to solve this problem? I hope you've spent a few minutes solving the problem yourself, so let's take a look at it. The setup is very similar to what we have done so far, so it's a change in aggregate demand equal to the initial change in one of the components of aggregate expenditure. In this case, that's the government purchases or government spending, $1 million. And then we can find the spending multiplier. We're given the marginal propensity to save, and we're given the marginal propensity to import. So it's 1 over MPS plus MPI. So that would give us a spending multiplier of 2. So at the end, the aggregate demand will increase by $2 million. Okay. One more question. But look at this question very carefully. It may look very similar to what we have seen so far. But when you look at it closely, there is a slight difference there. Suppose policymakers would like to increase the aggregate demand at its current price by $400 million by increasing government spending. Assume marginal propensity to save is equal to 0.35 and marginal propensity to import is equal to 0.15. How much increase in government spending is needed in this case? So once again, let's pause for a few minutes so that you can work on the problems. We'll come back later. So look at the question carefully. It is slightly different from what we have done so far. So far what we have asked to do is to find the increase or the change in the aggregate demand. So for example, we were given an initial change in investment. We are asked to find the total change in the aggregate demand. And then we were given a change in government spending, and then we were asked to find the change in aggregate demand. But in this case, it's different. In this case, the policymakers have already known the change in aggregate demand. They have targeted a change in the aggregate demand. So that's usually what happens in policy making. Policymakers have a target. So they have already set the target. They want the aggregate demand to increase by $400 million. And they have chosen government spending as the policy tool. So the question here is how much policymakers would have to do with government spending in order to increase the aggregate demand by $400 million. So the setup, as you can see, is still the same. We have the change in aggregate demand and the change in one of the components of aggregate expenditure. In this case, that's government spending, multiplied by spending multiplier. So what is different here is we are no longer solving for the change in aggregate demand because that's known here, right? So $400 million. And we can calculate the spending multiplier, so we get 2. What is unknown here is actually the change in government spending that is needed. So the rest is just algebra. what we need to do is to divide both sides by 2, and then you can see that the necessary change in government spending is $200 million. So the government, the policymakers, need to increase the government spending by $200 million so that at the end, the aggregate demand can increase by $400 million. Okay? So we are stepping closer to policy making. So now you can see that by setting a target, the policymakers need to calculate what is the size of policy tools that it will have to use. Lastly, we will want to spend some time talking about the limitations of spending multiplier. The formula of spending multiplier is a very useful one. However, it has its limitation. It doesn't take into consideration the change in the price level. The formula of spending multiplier has not taken into consideration the change in the price level. So that limits its implications. Okay? So take, for example, go back to the initial examples. So with an initial change in investment by 100 million, we found that at the end, the aggregate demand increases by $250 million. Okay? So that is shown by the horizontal distance between the initial aggregate demand curve and the new aggregate demand curve. So the horizontal distance. It doesn't have to be here. It can be any horizontal distance between these two curves. Okay, between the two aggregate demand curves. Okay. So this is the initial equilibrium output level, Y1. So you can see that with an increase in aggregate demand, the price level is actually not held constant at this level. The price level increases. Okay? So we have a new equilibrium price. We have a new equilibrium price which is higher, and the new equilibrium output level at Y2. What the spending multiplier tells us is this horizontal distance here. Because spending multiplier assumes that the price level is constant. So that means all we know is that the equilibrium output increases, but we don't know how much. Because when we apply spending multiplier, we are looking at how much the aggregate demand has increased at its current price level. That's $250 million. But we don't know the distance between these two. We don't know how much the equilibrium real output has changed. So that's a limitation of spending multiplier. We cannot tell the exact change in the equilibrium real output. But what we do know is that the equilibrium real output has increased, and the increase is less than $250 million, because this distance here is $250 million. I hope it is clear that this distance here is smaller than $250 million. Okay, so that's the limitations of spending multiplier. Okay, because spending multiplier ignores the change in the price level. If we allow an upward sloping aggregate supply curve, which is usually the case in this classroom setting, the increase or the decline in aggregate demand, so in this case that's an increase. The increase in aggregate demand drives up the price level. Okay? So if the price level is constant, then the real output will be here, right? However, the price level is driven up as the aggregate demand is driven up. So you can see that part of the increase in real output demanded is offset. So we're coming back here, right? So instead of here, we have a equilibrium real output at this level with a changing price level. Okay? So the change in the price level offsets some of the change in quantity demanded.